In this video, we're going to be talking about solving quadratics using what's called the quadratic equation or quadratic formula. So, real quick, here we have a quadrilateral. It's a four-sided shape. And anytime you want to find the area of a quadrilateral and you don't know the length or width, if they're variables, if they're unknowns, when you try to find the area, you get what's called a quadratic. So just a little intro there. And to solve for those missing sides, there's all kinds of ways that we have to solve them. One particular one is this quadratic equation, and the neat thing about the quadratic formula is that it works pretty much for any quadratic, whereas some of our other techniques that we'll learn pretty soon here don't always work for any quadratic. So this is a sure way to solve any quadratic that you see. The standard form of a quadratic looks like this. Some number in front of x squared plus another number in front of just x to the power of 1. And usually there is another number right off to the side there that doesn't have a variable attached to it. So that's its most basic form. This is what a quadratic in its most generic form will look like. There's always going to be different ways that it looks, but we'll try not to get too confusing right off the bat. So here is a nice quadratic in standard form already. A, we're looking for the value in front of x squared. What is the value of A? Well, it's 1. Usually, if you can't see it, if it's invisible in front of a variable there, it's usually 1. That's the value. B is the value that's attached to our x to the first power. Well, in this example, it's 3. And then the number on the end there is the value of C. It doesn't have any of these variables. That's just negative 10. So as long as you can always find the value of A, B, and C, you'll be able to use this quadratic formula here. The quadratic formula in its most basic form is the opposite of whatever B is. We're going to say plus and minus, which is kind of weird. The square root of b squared minus 4 times a times c. So it's pretty long here. And that's all divided by 2 times a. So it seems like an awful lot. If you can memorize it, it will be a lot more helpful. I like to say it to myself every time I do a problem, and that helps me memorize it. Alright, so let's see if we can apply the quadratic formula and actually solve this quadratic. When we solve a quadratic, we're talking about what does x equal. Okay, we want the value of x, so we go through all this just to find out what the value of x is. Alright, so here's our first example here. We're going to substitute our values a, b, and c into our quadratic formula. So the opposite of b, which is the opposite of positive 3, that's negative 3, plus and minus, we'll get to that in a sec here. The square root of b squared, so positive 3 squared, minus 4 times a, which is 1, times c, which is negative 10. I'm going to be dividing all of that after I simplify it by 2 times a, which is 1. Alright, so all you got to do is really just simplify. Start inside the radical. Treat that as like parentheses in your PEMDAS ordering. So 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times negative 10 is positive 40. So what do we get inside here? We get square root of 49. Well, that's a nice square that we can take the square root of. We still got our -3 out in front. Still haven't talked about what plus and minus means. And we're going to be dividing by, oops, what's going on? We're going to be dividing by 2 times 1, which is just 2. So the square root of 49 is 7. So we're doing -3 plus 7 divided by 2. That's going to take care of our plus here. But we also need to do, or simplify, -3 minus 7. That takes care of the minus 1 right there. And divide that by 2. So this plus and minus means we have to do both. We have to find both values. So -3 plus 7 is 4. And 4 divided by 2 is 2. So one value of x is 2. Let's get the other value for x. -3 minus 7, that's -10, divided by 2, gives us -5. So the two possible values for x are 2 and -5. If you substitute it, it should equal 0. What's 2 squared? That's 4. Plus 3 times 2, that's 6. Minus 10. Well, 4 plus 6 is 10. And 10 minus 10 is 0. So 2 definitely works. That's a value for x. Let's try -5. -5 squared is positive 25. Plus 3 times -5, well, that's -15. Minus 10. 25 minus 15 is 10, and 10 minus 10 is 0. So -5 also works as a value for x. Later on, we'll learn what the values for x represent in graph form. Actually, x-intercepts. Alright, let's do another example. Why isn't my thing working here? There we go. Alright, so the opposite of b again. So the opposite of -8 this time is +8. Plus or minus the square root of b squared, so -8 squared, minus 4 times a, and a is now 4, times c, which is 4. All over 2 times a, again 2 times 4. So solve under the radical first. -8 squared, that is 64. -4 times 4 is 16, and -16 times 4 is 64. So we got -64. Well, the radical just became 0, so really this whole part of the problem just went away. That's nice. We have 8, still divided by 2 times 4, so we have 8 divided by 8, and so our value for x is 1. So this time there's only one value for x, and that happens sometimes. Visually, it's really the tip of our graph. We'll get into that later though. So let's plug it in. Let's see. 1 times 1, 1 squared right here. That's 1. 4 times 1 is 4. Minus 8 times 1, that's -8. Get out of here. Let's write it over here. 4, what is going on? 4 minus 8 plus 4. Does that equal 0? 4 minus 8 is -4, and -4 plus 4 does equal 0. So x equals 1. Alright, let's keep going here. What if there's a missing term? If you ever don't have either b or c, if it's a quadratic, you're supposed to have a. A is always 1 at least. So you'll only be missing b or c. Well, they either equal 0 if they're not there, or they equal whatever they are when they're present. So if they're not there, they equal 0. So b in this case equals 0. It's not there. So that's going to make this problem hopefully pretty easy. The opposite of b is just still 0, plus or minus b squared, so 0 squared minus 4 times a, which is 1, and then times c, which is negative 9. All divided by 2 times a, which is 1. So 0 squared is 0, negative 4 times 1 is negative 4, negative 4 times negative 9 is positive 36. So we got the square root of 36. We still have a plus or minus there, and it's still being divided by 2. So the square root of 36 is 6, but we have two answers here. We got positive 6 divided by 2, which is 3, but we also have negative 6 divided by 2, and that's negative 3. So two answers on this one, 3 and negative 3. Check it. 3, if you substitute 3 squared, that's 9, and 9 minus 9 is 0. Well, this is why we have two answers, because negative 3 squared is also 9, and 9 minus 9 is still 0. So both of these are possible values for n in this quadratic. Alright, one last problem. Let's get back to that quadrilateral here. Let's do an area problem. This is why we need to know how to solve quadratics. So I got a little step recipe up here. Set up the equation and solve the area of the quadrilateral. Alright, so we do that by multiplying length and width. And if we don't know the values, we are going to get a quadrilateral with a quadratic area. So the length is x plus 9. And we multiply length times width. Width is x, so let's multiply these two things together here. We get x times x, that's x squared. And x times 9 is positive 9x. And we knew that if we multiplied the length times width, we would get the area. And the area, they tell us, is 36. So this equals 36. But we always want to put it into standard form. So keep following the directions up here. Move terms around so that the equation is in standard form and set it equal to 0. And then we can use our quadratic formula to solve. So to get this value over to where c should be, we need to subtract it from both sides. So we get x squared plus 9x minus 36. And there's nothing left on the right side, so we set it equal to 0. Now use your quadratic formula. Opposite of b, so negative 9. Negative 9 plus or minus the square root of b squared, so 9 squared, minus 4 times a, which is 1, times c, which is negative 36, all divided by 2 times a, which is 1. Simplify under the radical. So we get 9 squared, that's 81. Negative 4 times 1 is negative 4. Negative 4 times negative 36, well, that ends up being positive 144. If we add these two together, we get 225. And this ends up being a perfect square, and the square root of that is 15. So we got negative 9 plus or minus basically 15 divided by 2. So we got negative 9 plus 15 divided by 2 is one answer. Negative 9 plus 15 is 6, and 6 divided by 2 is 3. We also have negative 9 minus 15 divided by 2. Negative 9 minus 15 is negative 24. Negative 24 divided by 2 is negative 12. So anytime we're doing an area problem and we actually get two answers for x, we need to think about what's realistic. Well, really, x equals 3 is the most realistic. So 3 for x plus 9, that's 12, and 3 for x. If we add it all up, 24 plus 6 is 30.